A few weeks ago, I released the previous video on Flux, a comprehensive guide. As I mentioned at that time, compared to SD3 Medium, the open-source community has shown even more enthusiasm for Flux. On Hugging Face, the machine learning community, Flux and its derivative models have consistently trended on the leaderboards. During this period, we've seen the release of Flux models in NF4 and GGUF formats, which require much less GPU power, making them a blessing for users with smaller VRAM. Various LoRA models have emerged, allowing you to use graffiti-style LoRA, illustration-style LoRA, photography-style LoRA, and even a Black Myth Wukong LoRA with Flux. Different teams have also released their trained ControlNet and IPAdapter models. While the precision of image control and stable style transfer still lags behind SD1.5 and SDXL, it's undoubtedly a very promising start. ComfyUI developers have been busy as well, releasing new nodes and functionalities to natively support these new models. Overall, Flux's ecosystem is thriving. In this video, I'll introduce and review the latest additions to the Flux ecosystem, demonstrating them in ComfyUI. Let's start with the new models that have lowered the barrier for using Flux. While the original Flux models delivered great results, they were quite demanding in terms of VRAM. But now, with NF4 and GGUF format models, you can run them on GPUs with 8 GB of VRAM or even less, meaning most users can now enjoy Flux. In the previous video, I mentioned that the official Black Forest models are in BF16 format, offering higher precision but with larger file sizes. ComfyOrg and Kajai converted these to FP8 format, significantly reducing the file size by nearly half. You might ask, can we compress them even further? The answer is yes. But it can't be done recklessly, as the model quality would suffer. There are currently two different approaches that compress the data while preserving model quality, leading to the NF4 and GGUF series models. NF4 stands for Normal Float 4, stemming from an efficient fine-tuning method called QLoRA, which allows users to run most Hugging Face models across any modality, text, vision, multimodal, etc., at 4-bit precision. Since its release in May 2023, this technology has been widely adopted in the LLM space, helping slim down large language models, which are known to be quite massive. For Flux, 4GUI developer Iliasville, Jean Lumine, implemented a feature to convert models to NF4 format and shared her dev model files. However, to use NF4 models in ComfyUI, you need to install an external node provided by the official team, ComfyUI_bitsandbytes_NF4. But with the release of GGUF models, ComfyUI now recommends GGUF as the superior choice across the board, noting that LoRa's performance is much worse on NF4. So, they've stopped maintaining the NF4 node. It's not that NF4 isn't excellent. It's just that GGUF is better to use.so. Let's skip over NF4 and jump straight into GGUF. GGUF, GPT-generated unified format, is similar to NF4 in concept, both involving model weight quantization. However, llama.cpp, which generates GGUF models, offers more quantization strategies, resulting in various versions of GGUF models that provide great flexibility. Most new large language models, LLMs, like Meta's Llama 3.1 and Alibaba's Tongyi Qianwen, come with GGUF versions. City96 has created multiple versions of GGUF models for both Flux Dev and Schnell models. So, in practice, which one performs best? How should we choose? Take the Flux Dev model, for example. There are 11 different versions on the download page, with file sizes ranging from 4.03 GB to 23.8 GB. The file names contain letters like Q, K, and S, which are part of GUF's naming scheme and indicate the quantization strategy used. To simplify, the larger the number after Q, the larger the model, with less deviation from the original. Additionally, in terms of size, L greater than M greater than S. Of course, beyond these technical details, you're probably wondering which model offers the best value. After all, why not just choose the smallest one? llama.cpp provides a test chart that scores models across different aspects. However, raw data can be hard to interpret. Based on this data, a user named Gabriel Filankowski created a chart where the y-axis represents model size and the x-axis shows quality loss. By comparing this chart with the file list provided by CD96, it's easy to conclude that the best value is the Q6_K model, followed by Q5_K_S. These are slightly smaller than the FP8 models, but still exceed 8 GB. If your VRAM is insufficient and you encounter OOM issues, you can opt for the smaller Q4_K_S, which should run on an 8 GB VRAM card. If that's still too much, you'll have to go with the smallest Q2_K. Of course, the smaller the model, the greater the deviation from the original. I've written some code using the same prompts and parameters from the previous video to generate images with all the GGUF models, so you can compare them. You might ask, how does the FP8 model compare to GGUF? I'd say it's weaker than Q8_0, but not far off from Q6_K. However, the GGUF models use a trade time for space approach, introducing an additional decompression-like stage during use, so they run slightly slower. Therefore, I still recommend using FP8 if your GPU can handle it, and only switching to GGUF if you run into OOM issues. For this review, I've downloaded all the models and placed them in the ComfyUI/models/unet directory so I can demonstrate their performance for you. Theory is done. Now let's see how to use the GGUF series models in ComfyUI. First, it's a good idea to update ComfyUI since many features related to GGUF were only recently added. In the ComfyUI Manager menu, click Update ComfyUI. If your version is too old and this option doesn't appear, you can click the update_comfyui.bat file in the update directory. Once that's done, you'll need to install a new node to load GGUF models. Open the plugin page provided by CD96 and let's go straight to the installation section. The author's steps are simple. Git clone the project into the ComfyUI/custom_nodes directory and use python.exe from the python_embedded folder to install dependencies. Alternatively, an easier method is to open the ComfyUI Manager. Search for GGUF, and you'll find the plugin. Just click Install, and it will automatically handle the dependencies. I already have it installed. Whichever method you choose, make sure to restart ComfyUI after installation. With everything set up, let's start the demonstration. Load the image generation workflow I provided in the last video. Add a unet loader, GGUF, node. Adjust the node positions, and use Ctrl+G to create a new group for it. Double-click to rename the group GGUF. Open the options, and you'll see all the GUF models in the unet directory listed. As mentioned before, I'll choose the Q6_K version, which is closest to the FP8 model, and replace the previous model loader connection. I'll load clip and VAE separately. Keep other parameters the same and generate an image. Let's speed things up and check the result. It looks very similar to the image from the FP8 model. Let's bring that image up for comparison, and sure enough, they're almost identical. I'm using an RTX 4080 with 16 GB VRAM, so I can't fully showcase the advantages GGUF models have in terms of VRAM requirements. ComfyUI has a launch option that allows you to reserve some VRAM for the system. Let me set that up and simulate a smaller VRAM environment for testing. Close ComfyUI, open the launch file, and add Reserve VRAM 8.0. This means ComfyUI will reserve 8 GB for the system, leaving only the remaining 8 GB for use. Restart ComfyUI and wait for it to fully start up and be available. Add a new preview image node. And run again. Opening Task Manager, we can see the VRAM usage is indeed limited to around 8 GB. The image generated is identical to the previous one. However, this is a soft limit in ComfyUI, and it may not fully mimic an actual 8 GB environment. If you encounter OOM issues, I'd still suggest using a smaller GGUF model. City96 didn't just convert the base model. They also created a GGUF version for the T5 clip model, offering multiple formats. But I've downloaded so many models lately that even my 3 TB SSD is getting full, so I'll only download the Q6_K version. Place the downloaded file in the models/clip directory. Return to the workflow, and add a dual CLIP loader, GGUF, node. This node supports both GGUF and non-GGUF clip models. Select the newly downloaded Q6_K and the previous clip_L, choose Flux for the type. Replace the old clip input. Add another preview image node, and run. The resulting image looks almost identical to the previous one. The process for using other models is the same, so I won't demonstrate them all. But here's a comparison of the results with the same seed and parameters. The Q2_K image is a bit blurry, Q3_K_S lacks detail, but the rest of the versions perform fairly well. Here's another chart I generated, timing each model for 10 runs. Q5 and Q6 series took the longest, both exceeding 50 seconds. On the same environment, the FP8 version consistently took around 35 seconds. That wraps up the GGUF section. I'll remove the reserved VRAM setting and restore the full power of my GPU. Now, let's take a look at LoRA on Flux. LoRA, low-rank adaptation, is a simple yet highly useful component of AI image generation, covering style LoRAs, scene LoRAs, character LoRAs, detail LoRAs, and speed-boosting LoRAs. The development of Flux LoRA has been incredibly fast, with the community showing great enthusiasm. On certain model-sharing websites, the number of LoRAs for Flux far exceeds those for SD3 medium. And honestly, I've been working hard on training LoRAs myself. The original BF16 model from Black Forest, along with ComfyOrg and Kajai's FP8 models and the newly introduced GGUF models, all work with the majority of LoRAs. Only the NF4 models struggle with LoRA performance. But as mentioned earlier, we recommend using GGUF models instead. Using Flux LoRA in ComfyUI is very simple, and no extra nodes are required. I'll switch the model and clip back to Kajai's FP8 dev model and use that for the demonstration. Add a LoRA loader model-only node to load LoRA. Why this node instead of load LoRA? Because Flux LoRA doesn't need to connect to clip. This time, I'll demonstrate 4 LoRAs that I find very practical and effective: amateur photography, an illustration reality hybrid, Black Myth, Wukong, and ByteDance's new HyperSD, which reduces sampling steps. Let's go step by step, starting with the amateur photography LoRA. The images generated by the Flux dev model tend to follow certain photography aesthetics, especially with a pronounced depth of field, making them less like typical photos. This LoRA helps create more everyday, casual photos. Before using any LoRA, it's always best to check if the creator has provided any specific recommendations. On the release page, the author gives detailed advice: set the weight to 0.8, the sampling method isn't too particular, using hewn with beta or Ds with DDIM gives better quality but takes longer. The recommended resolution is 2048 x 1536 or 1536 by 2048, and the author also provides prompt formats with trigger words. I always follow the advice, except I won't change the sampling method, don't want to spend more time. Everything else I'll adjust. For the prompt, I'll describe 2 girls on a night market street. I'll also duplicate the image generation node to compare the same prompt without the LoRA. I'll connect both outputs to an image comparison node. Adjusting the parameters to clearly see the differences. Click to generate the images. The difference is quite obvious. The depth of field has changed significantly. In the LoRA-enabled image, the text on the sign at the stall on the left is sharp, not blurred, and the pedestrians behind the girls seem like they just walked by, much more like a casual snapshot. In addition to LoRAs that alter the image effect, there are LoRAs specifically trained to generate certain styles or scenes. For example, the second LoRA I'll demonstrate, Blended Realistic Illustration, allows for a blend of anime characters with real-world backgrounds, something that's difficult to achieve consistently with just prompts. The creator of this LoRA doesn't have specific parameter requirements, but I'll slightly reduce the resolution since the size I used earlier was too large. The prompt describes a cartoon girl in a swimsuit lying on a rattan chair by an outdoor pool, with the trigger word for blending reality and illustration elements. Click to generate and compare the results. With the LoRA, the character is fully in cartoon style, while the background remains realistic, matching the intended style. Without the LoRA, though the character is still in cartoon style, the background, buildings and trees, appears more animated, lacking realism. Character-specific LoRAs are also very popular, like this Wukong LoRA, which allows you to generate images of the trending game character Black Myth Wukong. Flux was released before the game, so it doesn't naturally recognize Wukong. But with this LoRA, and a simple prompt, you can reliably generate images of him. I'll set the LoRA weight to 1 and generate a full-body image. Change the resolution to 1024 by 1536 and describe Wukong as a business elite in the prompt, making sure to include the trigger word Wukong. Click to run. I'm very satisfied. Even though he's in a suit, Wukong's features are unmistakable, a perfect 1:1 representation. Without the LoRA, the result is just an ordinary man in a suit, with no trace of Wukong. As I mentioned earlier, GGUF models also work well with LoRA. I'll switch the base model to the GUF Q6_K version and continue testing Wukong. This is a great test since it's easy to see if it works. Sure enough, it works perfectly. Though the details differ slightly from the FP8 generated image, it's still a dashing Wukong in a suit. Finally, let's talk about a special LoRA, ByteDance HyperSD. It works similarly to the SDXL Lightning series models, allowing you to generate images with fewer steps. There are two versions, 8 steps and 16 steps. However, the official version doesn't support GGUF, so I'll switch back to the FP8 version and load the 8-step LoRA. The strength should be set lower, around 0.13. For comparison, I'll lower the steps in both workflows to match the LoRA at 8. The prompt will be a girl under the sunset. Click to run and check the result. Without LoRA, the image clearly didn't finish, the girl's hands are incomplete. I'll increase the steps to the standard 20. Add another preview node, and run it again. This time the image is complete. Those extra 12 steps allowed the model to finish the picture, with the limbs intact and more detailed. Comparing it with the LoRA-enabled image, I'd say the quality is comparable, but the efficiency of the 8-step HyperSD is clearly higher. Want to use multiple LoRAs at once? No problem. I'll show you how to combine the Wukong and illustration LoRAs. First, select the Wukong LoRA and set the weight to 0.8. Hold the Alt key, left-click, and drag to duplicate the LoRA node. Use the duplicate for the illustration LoRA and keep the weight at 0.8. When using multiple LoRAs, you might need to adjust their weights based on your needs. Update the prompt to include trigger words for both LoRAs. Change the steps back to 20. Disable the non-LoRA workflow. And click to generate. The result is an anime-style Wukong, successfully blending the effects of both LoRAs. If you experience abnormally high VRAM usage when combining multiple LoRAs, leading to OOM, out-of-memory, errors, it might be due to a bug. You can try updating ComfyUI, as the newer versions fix this, or switch to a GGUF model. Earlier, we used dev models. What about applying LoRA to the Schnell model? The process is essentially the same, with one key point. Choose a LoRA specifically trained for Schnell. While you can tweak the steps and parameters to make dev LoRAs work on Schnell, it's a bit of a roundabout way, and the results aren't as good. Let me demonstrate the standard use case. Switch the base model to Schnell and choose a Schnell-adapted style LoRA, which generates images in the style of Akihiko Yoshida. Set the weight to 1. Remove the extra LoRA loader node. And use the author's provided prompt. Change the steps to 8, and again. Compare the results with and without LoRA. Since we're using Schnell, remember to keep the steps at 8. Click to run and compare. The LoRA-enhanced image clearly showcases the distinct style. In the last video, I mentioned that XLabs AI and InstantX had released ControlNet models for Flux. In the past few weeks, not only have they released more models, but Shaker Labs and Misto AI have also shared their versions. ComfyUI and the advanced ControlNet plugin have been updated to support these new models. Although control effects aren't as precise as in SD1.5 and SDXL, and some models still have significant limitations, they're already useful in many scenarios. For example, I used canny, depth, and head to reference a portrait and generate a series of similarly composed photos. But since ControlNet is a broad topic, and this video is limited in time, I'll cover it in the next episode. The IPAdapter model is even more complex, requiring a lot of training steps and a diverse dataset. Although XLabs AI has released a version, the results are mediocre, and the images are still somewhat blurry. Even the ComfyUI plugin author Cubic shares the same sentiment. The currently available models are still in the early stages, so we'll need to wait patiently for improvements. Alright, that's all for today's video. I'll continue to update with more videos on the Flux series, including ControlNet, IPAdapter, LoRA training, and video creation. Stay tuned. All the GGUF models, LoRAs, plugins, and comparison images mentioned in this video are available in the description below. Feel free to check them out. See you next time.